everyone. I am Jagan Mohan. Today we'll discuss about the pressurized water reactor. See, we are using the nuclear power plant, thermal power plants for generating the power with the help of the thermal power, which produce the steam, and the steam is going to rotate the turbine and we are generating the power. So among these nuclear power plants, so there are mainly two types. One thing is pressurized water and boiler water reactor. So the pressurized water reactor is the most commonly used type of reactor in the nuclear power plants. Almost 60% we are going to use this type of reactor in nuclear power plants. And we discuss what is the difference between this PWR and PWR. We can differentiate the nuclear power plant on different bases, based on the neutron energy, based on the coolant, based on the moderator used, based on the fuel used. Based on the neutron energy, we can differentiate a nuclear power plant as a fast reactor and thermal reactor. And based on the fuel, we can differentiate as natural and enriched. And based on the moderator, we can differentiate as water, heavy water, graphite, and beryllium. And based on the coolant, we can differentiate as water cooled, gas cooled, liquid metal cooled, and organic liquid cooled. And now we'll see about the pressurized water reactor. So the only difference of the pressurized water reactor and boiler water reactor is that here we will pressure the water such that it will boil, but it will not become the steam. So here there will be two loops. So this pressurized loop and water loop. So here we are not going to make the steam directly from the core of the reactor. Okay. So since we are putting pressure, the water here will be circulating and without becoming the steam. So this water is going to exchange its heat in the heat exchanger or the steam generator. So there the normal water will be circulating, and there that water is coming in contact with this pressurized water, not directly. There the in contact with the surface of the pipe which is circulating this pressurized water. There that normal water will come into contact, and there the normal water will become the steam, and the steam is directed towards the turbine, and turbine is going to rotate, and ultimately we are going to generate the electricity. So that is the main criteria here. So here there is no direct contact of water or steam to the core of the nuclear reactor. You can observe in this slide how the steam generator is there. So in the steam generator, this pressurized water will be circulating from the steam generator, and to the core. Okay, so this is connected to the steam generator and the core. There the normal water is going to come in contact, and there the normal water will become the steam, and it is directed to rotate the turbine. So here the fuel used is enriched uranium. So since we are using the enriched uranium, that means which is higher than 92U-235, we are using the uranium oxides O2. So here it is having more efficiency here. So this UO2 is highly resistant to irradiation damage and well adapted to the high burn apps. It is also highly resistant to the corrosion of the water. So that's why we are using the enriched uranium here. So the advantage here is there is no direct contact, so there will not be any radioactive effect in the steam or the wastage of the exhausted steam, which we will condense and we will leave or recycle. So there is no radioactive effect since there is no direct contact. So which is good for the staff also, for easy for the staff, since we are having two loops, a pressurized loop and water loop. So the maintenance is easy. Here we will be having the high power density since we are using the enriched uranium. It is free from the radioactive, and the water we are using as the coolant is cheap. And the disadvantage is that the primary circuits will be having high temperature and high pressure, so which accelerates the corrosion, and the construction of that vessel is costly because we have to construct with stainless steel, and when you want to charge the fuel, you have to shut down the plant. So that means we are taking long time, more time gap, and the pressure in the secondary circuit is relatively quite low as compared to the primary circuit. So that means there will be less thermal efficiency here, and the fuel suffers radiation damage here. So the fuel we are using here suffer the radiation damage here. So these are the advantages and disadvantages of the pressurized water reactor. So we are having both advantages and disadvantages. This is the most commonly used because this is the most safe method of operating the thermal power plant and easy method. So since there is no direct contact with the core of the nuclear plant, so we are majorly using this type of reactors in the nuclear power plants.
Like, share and subscribe. Hit the bell icon for more updates.